Welcome back. Previously we have been dealing with the mathematical application of regression analysis. Let us discuss some of the cases that comes under the same category. Next case. For 17 observations on price, let it be x, and supply, let it be y, the following data were obtained in appropriate units. Sigma x is given, sigma x square is given, sigma y is given, sigma y square is given, and sigma xy is also given. Obtain the regression equations and also find the value of supply when the price is 35. So this is a type of a typical case that comes under a regression equation. Previously we have done a typical type of a regression type where you need to find all these values, and on the basis of these values you need to develop equations. And in this case the question directly given the values of each equation variables. So just substitute these variables in the equation and use the equations appropriately to find the value of unknown variable on the base of known variable. So first of all, in the question it is given, what is the supply when price is 35? So here only one part is given, that is you need to find the value of supply when price is 35. So one equation is need to find the value of this one, what is the supply when price is 35. But in the question it is mentioned that you need to find the two regression lines. That means finding two regression lines means finding two regression equations. So let us deal with that part. Let us find out the two regression equations. Since the values is already given in the question, just substitute the same in the equations. So we will begin with finding out mean. In almost all the cases of regression cases, you need to find the value of mean of x as well as mean of y. So mean of x is sigma x by n. Sigma x is already given 544 divided by 17 equal to 32. Likewise, mean of y is sigma y by n. Sigma y is given 244 divided by 17. You will get 14.35. So first of all, you have found out the means of x as well as mean of y. Once you found the mean of x and mean of y, you need to use the equation regression cases of y on x as well as x on y. And before that you need to find byx. I hope you know these steps and what is the meaning of byx and bxy. So we are going directly into the computation of byx and bxy. So we begin with byx. Equation is n sigma xy minus sigma x into sigma y divided by n sigma x square minus sigma x the whole square. Same for the next one, x on y, bxy equal to n sigma xy minus sigma x into sigma y divided by n sigma y square minus sigma y the whole square. So I hope you know the meaning of these two cases. So let us go with both cases simultaneously. So byx, here n is given 17 into sigma xy 8413 minus sigma x 544 into sigma y 244 divided by n 17 into sigma x square is 19040 minus sigma x the whole square. Sigma x the whole square is 544 whole square. By using the basic max, you will get the value 0.37. Likewise, you have to do the same in case of bxy. Remember, numerator will be the same. The only change that happens is the change in the denominator. So do it accordingly, and you will get the value of bxy is 2.23. Once you found the value of byx as well as bxy, next you need to use the regression equation of y on x as well as x on y. So first of all, let us begin with y on x. We know that the equation for y on x is y minus y mean equal to byx into x minus x mean. Similarly, the regression equation of x on y is x minus x mean equal to bxy into y minus y mean. And we have already found the value of byx as well as bxy. And we know the value of mean x and mean y. So substitute these details in the equations. y minus, we don't know the value of y minus y mean 14.35 equal to b by x 0.37 into x minus x mean is 32. Similarly, x minus x mean 32 equal to bxy 2.23 into y minus y mean 14.35. And just the case which we have discussed in the previous session, substitute the known values to the right hand side and unknown values to the left hand side. So it will be like this: y equal to 0.37x minus 11.84 plus 14.35. Here x will be x equal to 2.23y minus 1.44, and finally you will get y equal to 0.37x plus 2.51. So you have done one equation and another equation. So you have done both equations. In the question you are asked to obtain the equations of the two regression lines. See, you have developed two equations. Once you have developed two equations, sometimes in the question they may ask to find the value of one thing on the basis of another thing. Here it is given what is the supply when the price is 35. So which one is unknown? Supply is unknown, price is given. So supply means which variable, x or y? See, in the question it is given supply is y variable. So supply is y. So you don't know the value of y, but you know the value of x. So when the value of y is unknown, which equation is used, this one or this one? Definitely this one. This one is for using the finding the value of y. This one is for finding the value of x. See, y is in the left hand side. Left hand side is unknown variable. Here x is in the left hand side. So x is the unknown variable. Likewise, you have to use the equations accordingly. So let us go with this one. Given price is 35. Price in the question, the price was x. Y is supply. So y equal to 0.37 x plus 2.51. That is the equation. And 3.7 into the value of x is 35. So 2.37 into 35 plus 2.51, you will get 15.46. So when the price is 35, the supply of that particular item is 15.46. So this is how you have to find the value of a certain variable when the value of another variable is known. See, in this question we have found only one value, supply, because in the question you are asked to find the supply when the price is 35. If you remember the previous question, in that question the question was asked in both ways. Why the age of wife and husband was asked. In one case the age of husband is given, you need to find the age of wife, and another case you need to find the age of wife when the husband's age is given. So in that case you have used both equations. Here you are asked to find only one variable, so accordingly you have used only one equation. So remember the concept, familiarize the cases. So let us go to the next part. Finding the value of regression equations when the deviations are taken from assumed mean. Just like the methods which we have learned in case of correlation, in this situation also you need to find deviations. I hope you know how to find the deviation of a particular case. And just like the case we have discussed in case of a correlation, you need to find the deviation with assumed mean as well as actual mean. I hope you know how to find the case on the basis of assumed mean as well as actual mean, because the equation for finding the regression equations for assumed mean as well as actual mean is different. So you have to be very cautious while dealing with the regression where deviations are taken. So deviations means in the equation you have seen that there will be sigma x, sigma y, sigma xy, sigma x square, sigma y square, etc. So instead of we are using the x and y, you will be using dx and dy, just like the method which we have learned in case of a correlation. You know why we are using deviations? If you go to the previous question, you can see that there is a value 19040. That's a bigger value. If you come across a question where you have to take the square of a 4-digit number, how you are going to solve a regression case? So whenever the values of x and y go beyond a easy computation, you can go for a deviation method. So because of deviations, the value of the x and y can be minimized. Then your computation will be easy. That is why we are using deviations in the case of regression. So when the regression is found on the basis of deviation, the equation for finding byx and bxy will be different. The only difference is that you need to use d before every x and y variable. See, if you remember the previous equation, this equation will be very easy. We just substituted d in front of every x and y. See, so these are the equations for finding byx and bxy. All other steps are almost similar. So let us deal with a case, then you will get a clear picture. A panel of 2 judges P and Q graded 7 dramatic performances independently, awarding marks as follows. So there was a program in somewhere else. There was 2 judges P and Q, and they have watched 7 programs and they have judged the 7 programs and given marks for each session. And in the question, it is further mentioned that the 8th performance, here 1, 2, 3, 4, 5, 6, 7, only 7 is given. The 8th performance for which Q could not attend, or Q was not there, was awarded 37 marks by Judge P. P was there, Q was absent, and P has given for that particular 8th performance is 37 marks. If Judge Q has also been present, how many marks would be expected to have been awarded by him to the 8th performance? That is the question. So first of all, let us go to the basic step, computation of equations. So before we go into the computation part, let's substitute the values of P and Q in the equation. Since no information regarding x and y is given, let the marks given by P be x and marks given by Q be y. So from now on we will be using x and y. So x is given, y is given. We already took the total of x and y. I hope you know why we are finding the total, for finding the mean. And in here you have to be very cautious. This is a case of an assumed mean. So, and the next one, here only one regression equation is required, because in the question there is no mentioning regarding identify the 2 regression equations. You are asked to find the marks given by Q if he was present there, and the marks of the P is given. So you need to find Q when P is given, and P is assumed as x and Q is assumed as y. So here which one is unknown? Definitely Q is unknown, because Q is assumed as y. When Q is unknown, the equation we are going to is y on x. That will be y minus y mean equal to byx into x minus x mean. So finding out mean of x as well as mean of y. I hope you know how to find the value of mean of x as well as mean of y. You need to find the mean of x as well as mean of y, and you will be getting 43 and 38. Here the mean of x and mean of y is computed to substitute in the equation here, this one. And remember, we are dealing with a regression case where deviations has to be found out on the basis of assumed mean. Okay, so here you will be finding out the value of dx as well as dy, and for dx you need to take or find a value from the series. Never take this one, 43 or 38. So for the time being, let us take 42. If you take 43, it will be a case of an actual mean situation. So never take 43. You can select a value just preceding or succeeding this value. For the time being, I am using 42. So dx equal to x minus 42. I hope you know what is meant by dx and how to find dx. So x minus 42 means this value, each value minus 42. So you will get 46 minus 42, 4. Likewise, you will get dx the value 4, 0, 2, minus 2, 1, minus 1, 3 and 7. Once you found dx, you have to do the similar situation for dy also. See, we have already find the mean of y is 38, but we took 39 because it is a situation of assumed mean. So we have, you can take either 37 or 39 or any number which is almost closer to the 38, but never take 38 because it is a case of assumed mean. So here for the time being we are using 39. You can either use 40 or whatever number you can like. Anyway, make sure the value of dx and dy doesn't go beyond a certain limit. So once you found dx and dy, next you need to find dx square. Dx square means square of this one. And next one, dy square, that is square of this column. And finally dx dy, that is multiply these two columns. So once you found all these columns, just substitute these values in the equation. Byx equal to n sigma dx dy minus sigma dx into dy divided by n sigma dx square minus sigma dx the whole square. Just like the similar equation which we have learned in the previous session, just add d before every x and y variables, and n sigma dx, n is already given 7. Remember, here only we are studying the details of 7 programs or 7 performances. You may confuse that in the question it is given that 8th performance was there, likewise and like that. But never take 8 because in the question the complete details regarding 7 performance is only given. So here n is 7. 7 into sigma dx dy 14 minus sigma dx is 7 into sigma dy is minus 7 divided by n sigma dx square. 7 into dx square is 35 minus dx the whole square, 7 square. So by solving this part you will get 0.75. Once you found byx, substitute this value in this equation, you will get. And why we are using this equation? Because in the question it is said that when x is 37, estimate y, because 37 means it was a mark given by Judge P in the 8th performance where q was absent and you need to find the value of q. So we assume that marks given by PV is x. So x is 37 and estimate the value of y. So by substituting the same in the equation, y equal to 0.75 into 37 plus 5.75. I have directly gone into this part because I hope you know how to find this one from this one. By substituting byx here and by substituting the mean in the subsequent places, you can change this one into this one, y equal to 0.75 into, it was all 0.75x. So 0.75 into 37 plus 5.75, you will get 33.50. So this was the marks given, would have been given by Judge Q if he was present. So if the Judge Q were present at the 8th performance, he would have assigned the same score, that is 33.50. So this is a case of a regression equation identification when the deviations are taken from assumed mean. Almost similar to the steps which we have followed in case of a correlation. It's very easy, just go through it, familiarize the equations and make sure what is asked in the question. Whether it is what is meant by x, what is meant by y, whether it is x you have to find, or whether you have to find the value of y, or whether you have to find the value of x as well as y, whether you have to find all the two equations and which equation has to be used. All these things you have to be very cautious regarding all these areas, because it is an easiest part, and the main thing about the easiest part is you will surely end up with some careless mistake. So just go through it, familiarize the equations, understand the concept. We will discuss about another cases that comes under the same category in the next sessions.